Today you'll be learning lesson 4.4 on graphing a function rule. So let's talk a little bit about the graphs of a function. Okay? The graphs of a function represent all the possible solutions. Okay? Every answer, every output you could get for that situation. Okay? They have arrows at both ends. Okay? So most of your graphs are going to be a line, arrows at both ends, unless it has a set or limited domain. And what we're talking about then is usually real world graphs, so word problems. Okay? When they're a word problem, they usually do not involve your negative integers, okay? Which means your graph is only usually in quadrant 1. And here's my coordinate plane. Okay? So you might have either a ray, which means it's going to come out somewhere and keep going straight, okay? Or you may end up with a segment. Okay, where it's connecting those two parts. Okay, but it will usually not have arrows on both those ends. So to make or to graph a function, what we do is we make something called an input-output table. Okay, and I have one drawn here for you already. Okay, that's usually your input, which is x. Okay, your equation. Okay, and the last column is your output, which is y. Okay? So, 5 values, okay? If it's not a word problem, okay, we usually want to use -2 to 2, okay? Because then we show our negatives and our positives. Now, if it's a word problem, you're not going to start in the negative, so your table is going to start at 0. Right? And depending on what type of word problem it is, and you'll see some of these later, you might go by 50s, you might go by 10s, and where you find that out is by looking at the graph they give you. Right? The other thing, like you'll see in this first example, is if your x has a fraction, you want to count by your denominator. Okay? So if it's a fraction, count by your denominator, but you still want to have 5 values, 2 negative, 0, and 2 positives. Okay, so let's look at this first example I have here. It says, what is the graph of the function rule y equals 1/2 x minus 1? So I made my function table. My first column is x, second one is my equation, and if you want to put the y equals in there, you can, okay, but it doesn't have to be because this is your workspace, okay, and your last column is your output, which in our case is y, okay. So to solve it, okay, if you look here, I have 5 values, 1, 2, 3, 4, 5, and I chose these numbers rather than -2 to 2 because I have this fraction. My coefficient of x is 1/2, which means I want to count by whatever my denominator is, which is 2. So if I'm at 2s, I count -4, -2, 0, 2, 4. Okay, and on this function table, then we have to show our work. So when you do that, you take your x value, 1/2, substitute it in, -4 minus 1. That's my first step. That's my substitution. Right, notice I left myself some space, and that's to show the next step. Half of -4 is -2, and -2 minus 1 is -3. Okay, notice I'm still showing all my work, the substitution and the steps it takes to solve that equation or that expression. Okay, so I already did the next plugins for us. 1/2 of -2 is -1. -1 minus 1 is -2. Substitute in 0. Half of 0 is 0. 0 minus 1 is -1. Half of 2, plugging in that 2, is 1. 1 minus 1 is 0. Half of 4 is 2, and 2 minus 1 is 1. Okay, so what this gives me is ordered pairs to graph. Okay, and sometimes you'll see a 4th column over here, but I don't require you to show that but this would be the ordered pair, -4, -3. Okay? My x and my y. Okay? So to graph that function, I'm going to change my pen size here. Okay? I'm going to plot my ordered pairs. So my first ordered pair is -4, 3. So my x-axis, I'm going to go -4 and down -1, -2, -3. And there's my first dot. Second order pair here, -2, -2. So I'm at -2, going down to -2. 0, I'm at -1, 0, -1. Right? And at 2, I'm at 0. And at 4, I'm at 1. Okay? And what picking those numbers did me was give me dots on my graph that are exactly through those cross points. Okay? I don't have to approximate where those partial amounts are. Okay? And the last part to finish this graph is connect those dots using a line with arrows. I'm going to use my line tool. Okay. And again, that graph should have arrows at both ends because that table is only for the numbers we picked. Okay? This function doesn't tell us anything about it, so we need to assume it can keep going on forever and ever. Okay, so let's look at a different function. Okay, what is the graph of the function rule y equals x to the third power plus 1? Now this time when I look at x, okay, there is no coefficient. So you should notice my graph is going by ones, or my table is going by ones. Okay, so here I picked the -2, -1, 0, 1, and 2. I substitute in each of those numbers for x and solve the rest of my equation. So -2 to the third power. -2 times -2 is 4, times another -2 is -8. So I'm at -8 plus 1. Okay? -8 plus 1 is -7. Okay? When I sub in -1, -1 times -1 is 1, times -1 is still -1, plus 1 is 0. Right? 0 to the third power is 0, plus 1 is 1. Right? 1 to the third power, 1 times 1 times 1 is 1, plus 1 is 2. Right? And 2 to the third power, 2 times 2 is 4, times 2 is 8, and 8 plus 1 is 9. Now if you notice, this one's going to give us a nonlinear function. It does not have a constant rate of change. Here I'm changing by 7. Here I'm only changing by 1, another 1, and then by 7 again. Okay, so this is a nonlinear graph. Once I've done that work, I'm ready to graph my equation. Okay, so my first order pair was at -2, -7. Now my graph isn't quite big enough, but I know this is -6. So -2, -7 is going to be right about here. -1, I'm at 0. Okay. At 0, I'm at 1. At 1, I'm at 2. And at 2, I'm all the way up at 9. So that's way up here. 6, 7, 8, 9. Okay, and I'm only putting that there to kind of help me see my graph is going to look like. Okay, so I got to connect those dots. Again, having the arrows at both ends. Okay, so not all your graphs are going to be perfectly straight lines, but unless it's a word problem, it again needs to have those arrows at both ends. Okay, let's look at another type. Okay, so here I have an absolute value function, right? Meaning I needed to, all my answers should end up being positive. Okay, so when I make my table, okay, it's no coefficient on x. Okay, I'll move this out of the way here. Okay, there's no coefficient on x. Okay, x is all by itself, so my table is again from -2 to 2. So I substitute in those numbers for x, and -2 minus 2 is negative 4. Taking the absolute value of that gives me an answer of 4. Subbing in negative 1 minus 2 is negative 3. Absolute value is a positive 3. 0 minus 2 is negative 2. Absolute value is 2. 1 minus 2, negative 1. Absolute value is 1. 2 minus 2, 0. Absolute value of 0 is still 0. So I have my ordered pairs to graph. So the last step is to plot them on my coordinate plane. My first ordered pair is negative 2, 4. So at negative 2, I'm up at 4. At negative 1, I'm up at 3. At 0, I'm at 2. At 1, I'm at 1. And at 2, I'm at 0. Okay? So what that looks like, and since it's absolute value, I need to think about this graph. Okay? This one, if I think about it, when I connect these dots, okay, my graph is never going to go past 0, right? On my x-axis, it's on the y-axis. It can't go negative, so I need to think about what's going to happen over here. So I'm going to extend my table one spot. And if I plug in 3, 3 minus 2, absolute value, is 1, whose absolute value is 1. Okay. So when I do that, my graph, 3, I'm back up at 1. Okay, so there now my values are going to start going back up. Okay, so I'm going to make this side go back up and kind of mirror that other side. Okay, so if you think of an absolute value function, make sure you show it should end up being a V. Now let's look at some word problems. Okay, it says the function rule W equals 8G plus 700 represents the total weight W in pounds of a spa that contains G gallons of water. What is the reasonable graph of the function rule given the capacity of the spa is 250 gallons? So the total weight can only be, or the total number of gallons is 250. Okay? So for my table, I already started making it again, right? This time we're not using X and Y. Your input is whatever's on this side, so it's G. Here's my equation. My output is W, right? Now this time, since it's a word problem, I can't plug in negative number of gallons, so it don't exist. So I started my graph at 0. And here, my table, if you look, every other one is 100, so these ones in the middle are 50, right? So I did my 5 values, right? But the problem is that there's a capacity total of 250 gallons. So I'm going to make one more, even though I already did 5, of 250, so that I can see where my last point goes. Because that can range from 0 to 150 or 250, right? Which means we're going to have a segment for our graph. Okay, we can't go past that point, so I need to know that ending value. Okay, so let's do our work. Again, showing my work in this middle column, so substitute in 0. 8 times 0, 0, plus 700 gives me 700. Okay, which means the spa was starting with a weight of 700 pounds. Okay, if I plug in 50, 8 times 50 is 400. 400 plus 700 is 1100. Okay. 8 times 100 is 800. Plus 700 is 1500. 8 times 150 okay, is 1600. Whoops, is 1200. Ahead of myself. 1200 plus 700 gives me 1900. And then we plug in 200. 8 times 200 is 1600. Plus the 700 is 2300. And now I'm doing that last value, 8 times 250 plus the 700, so that whole equation, 8 times 250 is 2000 plus 700 is 2700. Okay? So the function W equals that, the total weight in pounds. Okay? What's the reasonable graph of a function given the capacity is 250? So my first order pair is at 0, 700. At 0, 700, this must be 500, so it should be about right here. Right? At 50, I'm at 1100. Right? At 100, I'm at 1500. At 150, I'm at 1900. At 200, I'm at 2300. And at 250, I'm at 2700, so 26, 27. Okay, and remember, that's the farthest I can go, so I'm going to connect those dots with only a segment, okay? And I know I should connect them for this because I can have partial pounds and I can have partial gallons. Okay, so there's my graph for that problem. Okay, now the reason I said I connect them is because there's two different types of graphs. We have our continuous graphs and our discrete graphs. Okay, continuous is a graph that is unbroken, shown with a line with arrows. And it doesn't have to have arrows. Okay, that last one was our segment. Okay, but what that really means is they're connected. Right? Whereas in a discrete graph, the graph is composed of distinct isolated points. Okay, there's no line connecting those points. Okay, continuous versus discrete. So let's look at another word problem. Okay. The amount of water in a wading pool in gallons depends on the amount of time t in minutes. The wading pool has been filling. As related to the function w equals 3t. Again, notice our input is t, our output is w. They want me to graph the function rule and decide if it's continuous or discrete and justify that answer. Okay? So again, looking at my graph they gave me, okay, they're going by 1 in our time, so I went by 1s in my table, started at 0 because I can't fill water for a negative number of minutes. Okay? So substitute 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. And 3 times 4 is 12. So I have my points. First one, 0, 0. Notice their word problem graph is labeled on the X, the Y, and has the title. 1, I'm at 3. Okay. 2, I'm at 6. 3, I'm at 9. And 4, I'm at 12. Okay, now they didn't tell me of anything about the maximum amount of water. I know there's going to probably be one because it's a pool, but they didn't tell me what that was, so I'm going to connect these with a ray. Okay, can't go past 0 or I'd be negative. Okay, and then I can keep going. They didn't tell me a limit. Okay, now connecting. Since I connected them, that tells me we have a continuous graph. Okay, and the reason I can connect them is because I only have an exact number of gallons. And if you look at here, can it only be counting by 3s? Right? Can I only have 3, 6, 9, 12 increments of 3 gallons? Okay? Can I only fill for exactly 1 minute? Maybe I fill for 3.5 minutes. Okay? So there is different intervals here that we don't have dots at, but they do still exist. Okay? So it's going to be a continuous data because can have partial minutes, partial gallons of water. Okay, I might end up filling it to 12.5 gallons. Okay, I don't know that limit, right? So that's what I have to have. I can have partial amounts. Okay, another one. Okay. Graph the function rule, explain your choice of intervals on the axes of the graph, and tell whether the graph is continuous or discrete. Okay, so the cost D in dollars for a parking pass depends on the number of whole weeks W you purchase. So whole weeks is a hint right there. This is represented by the function rule D equals 25W. So my table, 5 values, okay? W is our input, D is our output, right? So I went by 0, because in a real life, do we have a negative number of weeks? No. And I went by ones because I can have 1 week, 2 weeks, 3 weeks, 4 weeks, right? I could have chosen to go by 5s, but unless it's something that's already graphed, you should usually choose ones, right? So 25 times 0 is 0. 25 times 1 is 25. 25 times 2 is 50. 25 times 3 is 75. And 25 times 4 is 100. So I have points to graph. 0, I'm at 0. Okay? Now, on my x, I chose to go by 1, so I'm going to number that by 1s. Numbering all the way to the end. But for my y, I probably don't want to go by 1s, since these are all changing by 25. So I'm going to choose by going by 25. 25, 50, 75, 100, 125, 150. Okay? And we need to also put labels. Okay? Now this we are talking about W representing the number of weeks. Okay? And this represents our number of dollars. Okay? Or our cost. Okay? If you want to put cost, remember you should have dollars in those parentheses. Okay? And we are talking about, we need a title, a parking pass. Okay. So now my dots. 1, I'm at 25. 2 is at 50. 3 is at 75. And 4 is at 100. Okay, now this time I'm not going to connect them. Okay, so that makes this data a discrete graph. Okay, and it's discrete because I can't have partial weeks. Okay, so then it also wants me to explain my choice of interval on the axes. So here, so the x, I went by 1s because have to have whole weeks. So 1 apostrophe s to represent the whole weeks. Okay. On my y-axis, okay, I went by 25s because my outputs went by 25s. And where that comes from is that they're charging us $25 per week. Okay? Per week. Okay? So there's that one. Okay? And then last one. Okay? Your friend's graph of y equals x plus 3 is at the right. Describe and correct your friend's error. Okay, so in order to figure out their mistake, I made my function table. And this time, notice, I started at -3. And the reason I did that is because I look at their graph, they started at -3. Okay, so -3 plus 3 is 0. We're good there. -2 plus 3 is 1. I went up to 1. Right, so we're good there. -1 plus 3 is 2, so at -1, I'm up at 2, we're good there. So 0 plus 3 is 3. That's 0, I'm up 1, 2, 3, so we're good there. And at 1, I'm up, okay, 1 plus 3 is 4, and we're good there, okay? So mistake that they made was actually not in their work, but that this was not a word problem, so their mistake was that they should have connected it with a line. Okay, and I wouldn't know that was the only mistake unless I went through and I checked their work. Because this wasn't a word problem, it doesn't have any set domain or range, so I should have had that connected. So first dot, second dot, third dot, 0 we're at 3, and 1 we're at 4. So their only mistake was not connecting those dots with a line. And there you have graphing a function rule.